Okay, welcome back. We're working on 11.4 now, which are equations that have the form of a quadratic equation. Okay. So what was the quadratic equation, first off? Let's remember, it's not the quadratic formula we're talking about, it's the actual equation. So that was ax squared plus bx plus c equals 0. Right? And then we would generally solve this by factoring and then setting the factors equal to 0. So you'd set up your parentheses equals 0 and then hopefully factor it. Okay? It turns out that you can generalize this and basically put anything in for this x. So you can have literally anything imaginable, and you could literally put a smiley face in for x, and so long as it has the form of something squared plus something plus c equals 0, that's a quadratic form. Okay, and we can go ahead and factor and solve it. So let's take a look here. Problem 2, I have x to the 4th minus 13 x squared plus 36 equals 0. Okay, so I think you can appreciate, certainly there's this correspondence between the individual elements. Okay. Secondly, you can think of it as something squared if you need to, by just rewriting it using your rules of exponents. Okay, so x to the 4th is really just x squared squared. So the something that's being squared is x squared itself. And then we have minus 13 times something, in this case the x squared, and then plus 36 is 0. We attempt to factor it in the same way as before, and you kind of just pretend instead of x squared it's just an x, but instead of writing x, write x squared. And then you're thinking the signs have to be minus minus. Okay. And then what times what is 36, but adds to 13. Okay, so I don't know, 12 and 3, maybe. I don't know, that ain't gonna work. 6 and 6. No, how about 9 and 4? Yeah, that'll work. So we have a factorization. It turns out you can go ahead and factor this again. Okay, so then x minus 3 times x plus 3, those are just differences of squares. This guy, x minus 2 times x plus 2. Okay. And then you could set each factor equal to 0, and you'll have 4 solutions. So x minus 3 is 0, x plus 3 is 0, x minus 2 is 0, and x plus 2 is 0. So you get x is 3, or x is negative 3, or x is 2, or x is negative 2. Okay. Okay, so let's look at another one like that. So I have problem 6. X to the 4th plus 4x squared plus equals 5. Okay, so first we want to get it into the quadratic form, so set it equal to 0 by subtracting 5 from both sides. We have x to the 4th plus 4x squared minus 5 is 0. And then we could set up our parentheses as usual. And then here and here, instead of x and x, I'll have x squared and x squared. And then the signs have to be plus minus. And then you're thinking what times what is 5, but subtract to be positive 4. So 5 and 1 with a bigger guy is positive. We could factor the x squared minus 1. You could also use the square root property, though. Okay, so let's just use the square root property this time. From this factor, you see trying to solve it will not give you a real solution. Okay, it'll actually be imaginary, and we're not going to usually include them, but I think in this section they want them as answers. So if you do square root property, x is equal to plus or minus square root of -5. And then you can march the I out the back door. So x equals plus or minus radical 5i. From the x squared minus 1, if you solve for x squared, you have x squared is 1. And then square root property says x is plus or minus square root of 1, which is just 1. So let's look at another one. This one's a little bit different. So 8x plus the square root of x minus 6 is 0. Right, so this time it's like, what's being squared? How is this quadratic? Well, you can rewrite x as the square root of x squared. And then you have plus just the square root of x, and then minus 6 is 0. Okay, so the thing that goes here and here is the square root of x. And then we want plus minus, and we have to think to ourselves, what times what is 3, but adds to 1, well, it'll be 3 and 2. Okay, and then we could solve these guys. Square root of x plus 3 is 0. These are radical equations, so at the end of the day, you are actually going to have to solve these, sadly enough. Okay? So that was one of our forms that we actually have to check. So here I have square root of x is -3, and if I square both sides, we'll get x is 9. Over here, square root of x is 2, and if you square both sides, x is 4. Very quickly, right here, there's kind of a red flag. You'll never have the square root of something being negative, so I think this solution will not work. Okay? But we check anyways. So I'm going to plug this guy back into the original equation. So I have 9 plus the square root of 9 minus 6. I want to see if that's 0. So I'll have 9 plus 3 minus 6. And I'm asking myself, is that 0? It doesn't look like it, does it? 9 plus 3 is 12 minus 6. And certainly 6 is not 0. So that answer does not work. We can cross it out. Plugging 4 into there, I get 4 plus radical 4 minus 6 is 0. In other words, 4 plus 2 minus 6 is 0. In other words, 0 is 0. Okay, so this one does work, and we just have one solution. Okay, let's try another one like that. This one is different. It's the same, but it looks different. And the reason why it's different is because they are going to rewrite square root of x with a rational exponent. So remember, square root of x is the same as x to the 1/2. So let's take a look. This is number 10, and I have x minus 6 to the x to the 1/2 plus 8 is equal to 0. Okay. So in this case, again, it's if you don't see it, what's being squared here, it's square root of x squared, or if you'd rather, x to the 1/2 squared, right? And then minus 6x to the 1/2, if you'd rather, 6 square root x plus 8 is 0. Okay, I'm just going to go with the fraction exponent with x to the 1/2. So it'll be x to the 1/2 times x to the 1/2. And then what time, the signs have to be minus minus. And what times what is 8, but add the 6, 4 and 2. And then I need to solve these two, set them equal to 0 and solve them. They are radical equations, so you have to check your solutions. I'm going to square both sides, so I'll get x is 16. Square both sides here, and I get x is 4. Now I need to check these by plugging them into the original equation. So I'll try 16. So 16 minus 6 times the square root of 16 plus 8, seeing if that's 0. So I have 16 minus 6 times 4 plus 8 is 0. And then I have 16 minus 24 plus 8 is 0. And then I have 8, negative 8 plus 8 is 0, and that's true. 0 is 0, so that's a solution. That works. Check the other guy. I have 4 minus 6 times 4 to the 1/2, in other words, 6 squared root 4, and then plus 8 is 0. So I have 4 minus 6 times 2 plus 8 is 0. And then 4 minus 12 plus 8 is 0. And of course, that 0 is 0. So these are both solutions this time. Okay, let's look at a couple more variations on this theme. So probably about 5 more of these, and that'll do it for this section. So 14. What do we have this time? So I have x plus 3 squared plus 7 times x plus 3 minus 18 is 0. Right? So the thing that's being that's acting like our old x squared is the x plus 3. So when I go to factor it, I'll have an x plus 3 here in the first place. And then the signs from this have to be plus minus. It looks a bit funny, but you know, I need two numbers that multiply to be 18, but then subtract to be 7. So we're thinking 9 and 2, and the 9 has to be positive. The bigger number has to be positive. And then we could set each equal to 0 and have our solution. So x plus 3 plus 9. The parentheses are not important. So we have x plus 12 is 0, and then x is negative 12. On this side, I have x plus 3 minus 2 is 0. 3 minus 2 is 1, so x plus 1 is 0. And then finally, x is negative 1. So those are our two solutions. We don't need to check them. Let's take it up another notch. So 18, I have x squared minus 2x squared minus 11 times x squared minus 2x plus 24 is 0. This is still quadratic. Okay, so it basically is the idea here is it's like factoring x squared minus 11x plus 24 equals 0. It's just that idea. Okay? Except instead of x, you have x squared minus 2x. Okay, so I'm going to take my x squared minus 2x. Go ahead and put that in my parentheses. Okay. Then the signs have to be minus, minus, based off of this and this. So what times what is 24, but adds to 11. So we're thinking 8 and 3. Okay. And then I have to solve these two equations on their own. So you'll probably factor them. So it depends on how you want to do it. I think I'm just going to extract everything. The parentheses don't matter. And then solve these equations. So over here I'll have x squared minus 2x minus 3 is 0. Okay. So on this guy I'll have x, looks like minus 4 and then x plus 2. So here x is 4 or x is negative 2. On this end of things, I have x minus 3 and then x plus 1. So the solutions from this part, x equals 3 or x is negative 1. Okay, so we have 4 solutions there. Again, no need to check. Another sort of variation on this theme, I have 20x to the negative 2 plus 9x to the negative 1 plus 1 is 0. So this time, it's x to the negative 1. It's kind of like you could cheat a little and just take this variable and plop them there and there. And then the signs have to be plus plus. And then I need something times something that's equal to, whoa, I need to put some numbers in front of these, don't I? So this has to be 1 and 1, but then I'm going to have to put 5 and 4 in front of the x to the negative 1s. So if you allow me to, I'm going to smush those numbers in. This is a 4. Hopefully that's legible. Then you could take each of these guys and set them equal to 0. Okay, so these guys are rational equations. So x to the negative 1 is the same as 1 over x. So the first guy is just 5 over x. We want to be a little careful that x does not equal 0. That's a restriction. Okay. And then solve. So I multiply both sides by x. On the right-hand side, when I distribute, I get 5 plus x. On the left-hand side, I'm just getting 0. So at the end of the day, x is negative 5. Okay. Then from this equation, 4 to x to the negative 1 is the same as 4 over x to the positive 1. You know, we're not going to put a 1 here. It's a bit silly, so we just 4 over x is good enough. Again, we have a restriction. X cannot be 0. Okay, and I got to multiply both sides by x. And over here, when I distribute, I'll get 4 and then plus x. On the right-hand side, I have 0. So my other solution is negative 4. And neither of these answers conflict with our restriction, so they're both good. Okay, sometimes, obviously, they're not going to factor, but that's okay. You have the quadratic formula now to solve these quadratic forms. So 24, I have a similar situation as to before. First, I set it equal to 0. Okay. And this time, it's not going to factor, right? There's just no way to make it work out. You know, what times what is 4, but subtract to be 6. I mean, it's always going to be, the middle term will always be less than 4 if you play that. Well, actually, it's what times what is 4, but add the 6, right? So it's a negative times a negative. But there's no way to get to 6. Any multiple, any factor of 4, any factorization of 4, when you take those factors and add them together, they will never reach 6. You know, 2, 2 is 4, 1, 4 is 5, and that's it. It'll never get 6. So long story short, we cannot factor this. We have to go to the quadratic formula. So when you go to the quadratic formula, what you're going to do is take your sort of quote-unquote x term. So it's basically just this. It's the thing that if we had factored it, we would have put here, right? So you take this thing and you're plopping it here. And then you set that equal to the result of the quadratic formula. So this time then, I need an a, b, and c value. The a is the thing in front of the x to the negative 2. The b is the thing in front of the x to the negative 1. And then the c is the constant term. And I plug that in my quadratic formula. So it's x to the negative 1 equals negative b, so 6, plus or minus the square root of b squared, 36, minus 4 times a times c. And then that's all over 2 times a. That equals 6 plus or minus square root of 36 minus 16, all over 2. Then that'll equal 6 plus or minus square root of 20, all over 2. There's a restriction here. We can't have x being 0 again. Okay, so I just keep that in mind. or sorry, we can't have, yeah, exactly. So I'll talk about that here in a sec. All right, so anyways, let's just do one thing at a time. Get ahead of myself there. So anyway, 6 plus or minus, because we're not really solving for x yet, right? We're getting 1 over x is this thing, and then we'll solve for x. So it's neither here nor there. Okay, so I can march out perfect squares. Square root of 20 is 4 times 5, and that's all over 2. So I have 6 plus or minus square root of 4 is 2, and then root 5, and that's all over 2. And then I can factor a 2 out of the numerator. So I have 3 plus or minus root 5, all over 2. And then I'll have 3 plus or minus root 5. Okay, so our x to the negative 1 equals this thing. So there's 2 answers here, 3 plus radical 5 or 3 minus radical 5. So you have to set those up, because we haven't really found x yet. We found x to the negative 1. So x to the negative 1 is either a 3 plus radical 5, or x to the negative 1 is 3 minus radical 5. So these turn into rational equations. So I have 1 all over x is 3 plus root 5. So I'm going to multiply both sides by x, or maybe even quicker, we can cross multiply, right? Or I don't even know if that's going to be any quicker. No, let's do that then. Cross multiply, you have x times 3 plus root 5 on this side. On the other side, you have 1. I want to divide both sides to isolate x. Okay. And here, x is 1 all over 3 plus root 5. Of course, we have this restriction here. X cannot be 0. Okay. This is not 0, so we are good. All right, so let's go on to the other guy. 1 over x is 3 minus root 5. Again, we could cross multiply if you want. So you'll have x equals, or sorry, x times 3 minus root 5 equals 1. Divide both sides by 3 minus root 5. So you'll get x equals 1 all over 3 minus root 5. And again, the only restriction from this equation was that x cannot be 0, which is what I was babbling on about up here. I should have waited until we were down here. Obviously, x is not 0, so these are our solutions. Okay? All right, let's look at one more, and then we'll call it quits for this section. So here's problem 28. We have x to the 2/5 plus x to the 1/5 minus 2 is 0. Okay, so we can pull this guy out as our x term, quote unquote x term. So we'll have x to the 1/5 times x to the 1/5. And if you multiply these, you would definitely get this. So you may even want to be trying that in your head to make sure this really is of the quadratic form. Because if this times this did not equal that, then you would be out of luck. Okay, so the signs have to be plus minus, and then we need the bigger number to be 2. Here we have a 5th root. X to the 1/5 is a 5th root of x, plus 2 is 0. And then again over here, the 5th root of x minus 1 is 0. Right, so isolate the 5th root x. And then take the 5th power on both sides. So you'll have x is negative 2 times root 4, 8, 16, 32. Over here, 5th root of x is 1. Take both sides to the 5th power, and so x is just 1. When you have odd power roots, you don't necessarily need to check your solution unless you forget that you don't necessarily need to check your solution, and then you have to check your solution, right? So that'll do it, and we'll see you next time.